In this video, we will try to understand the integral calculus and what its physical significance is. Let's get started and start with a problem statement where we want to find out the area of a curve. Let's say we have a parabola, very simple parabola that we can plot y equal to x squared, and what we are trying to do is we'll plot this parabola which will look something like this. Okay, and this is x-axis and this is y-axis, and we are given to find out what is the area of this parabola between, let's say, x is equal to 2 and maybe at x equal to 5, this particular the area between these two figures. Now we know that there is no standard way of finding the area. Like if we are given a find area of a rectangle of x and y, I know that the area is xy, but there is no standard math way to calculate this. So one way we could do probably approximate is by splitting this shape into many small vertical strips like this, and calculating the y point of each of these strips. Each strips could be looking something like this, and then if we could keep it infinitesimally small, then this height we can find by this equation y equal to x square. For example, when x equal to 3, y is equal to 9, and that way, and we can divide this strip of, let's say, between x equal to 2 to x equal to 5 in 10,000, 1 million different parts, and sum them up all, and we'll get an area. But that's still going to be an approximation. In integral calculus, what we do is we do the same thing using a integral formula, and that is something we can derive, and that's something I will come in another video. The way we do is this: we integrate this function y. This is nothing but this dx represents this small little that stripped length we talked about, and we multiply the value of y at point x, we call it y, and we sum it, and sum these small little parts, and let this number of divisions tend to infinity. That is what we call an integration. Now here in this particular y is equal to x square, and there is a standard formula for the integration of x square. X to the power n when integrated gives x to the power n plus 1 divided by n plus 1. We apply this formula, so we get x cubed divided by 3. Now, if this is an indefinite integral, if this integral is performed between certain values, we put those bounds between x equal to 2 to x equal to 5, and that's why in between 2 and 5, the way we calculate is we first find this value of this integrated definite integral. We write 5 cube and then by 3, and then minus this 2 cube divided by 3. And if we somehow, for example, you can I will let you do this exercise. If you divide it into, let's say, 5 6 different 10 parts, and calculate the area using those individual strips, and then compare it, this solution and that solution are going to be very close. So for example, this one is 125 minus 8 divided by 3, or approximately 118 divided by maybe 117 divided by 3. So that is how you calculate the integral calculus. That's one application of integral calculus. There are many other such applications and it's very important you understand and practice it. In actual your exams, you will have to be given could be given many such functions. There are formula for many of these functions, standard functions. The how about if it becomes something like a fraction, or becomes sine x, cosine x, trigonometrical, exponential, logarithmic, etc., etc. Make sure you practice a lot if you are preparing for an exam.